This is how we test our model 4RH Blockhead spindle. You can see in there is one of our test balls that we make that's round to about 11 nanometers. In this test, we're rotating it on top of a 4-inch blockhead with an encoder on it to give us our encoder signals for the test. You can see here we're looking at about 9 nanometers of synchronous error for a radial test, which is pretty good for an oil bearing. This particular test points out why it's so important to be able to do error separation, because you can see that the spindle is looking better than the test ball, but that's just because that's the way the error is lined up. Now we're looking at the oil supply, which is especially made for our oil spindles, and it's turning out to be a almost perfect spindle.
Also keep in mind that's with an 11 nanometer ball.
Oh, okay. Now Henry is setting up to do an axial test on this spindle, which is a little bit tricky to get the capacitive probe just exactly the right height over the test ball. Using a Lion capacitive sensor. And, it looks like he's got it just about perfect. The spindle on the bottom is the blockhead for the motion, and the spindle on the top is the one that's actually being tested.
Yeah, that's pretty dang good.
I would say. The fundamental is 2.9.